Hello and welcome everyone again. So today, previously we have talked about LED circuits and of course our microcontroller, which is the PIC18F4550. So today we are dealing with the same microcontroller, but we have a little bit different circuit, a little bit different outcomes and objectives that we are looking for. So first of all, this is the circuit, and I will go through the question itself, or the task that we have, which is we should have 8 LEDs, and of course each LED has a number in order from 1 to 8, and I want two buttons where I press the first button, only LEDs with even numbers will work. If I press the other button, only LEDs with odd numbers will work. That's our objective. So I already constructed the circuit using our software, which is the ISIS Professional Proteus, and instead of constructing the circuit all over, um, saving time and going through the circuit, you can learn by going back to the previous video, how we came up with all those elements, all those components. From where it's easy, from here pick library and pick from library, and then you just write down the component that you're looking for, and then you'll find it, pick it and just place it whatever you want. And yeah, so we have already come up with our circuit, and I will go through the circuit, of course. What we have over here are our buttons, first button, second button, and as I said, the objective is whenever I press the first button, only LEDs with even numbers works, and whenever I press the second button, only LEDs with odd numbers will work. So it depends, first button even, odd, or second button even or odd. It's up to your preferences. Of course, we have our resistance over here. Why? We have explained that in the previous video, but it's just the matter that we have our power supplies over here, and if there are no resistance, if there's no resistor over here, so the circuit is going to be shorted. It's connected to ground, everything is going to be shorted, and there's no supply, there's no power supply for the button. So we put our resistance over here so that the button will work. Of course, we have our microcontroller over here, the PIC, the PIC18F4550, and what we have over here are our LEDs. As you can see, starting from 1 to 8, each LED has a number. So the LEDs with number 1, 3, 5, and 7 are odd LEDs, and LEDs for 2, 4, 6, and 8 are even LEDs. And of course, we have all connected to the ground. As you can see here, all connected to the ground, and all resistors, all LEDs are connected to our resistance over here, and then to the ports where the output is, or where we're gonna set the output. So, and of course, our power supply over here for the microcontroller itself. So I think the circuit is quite clear, nothing is complicated about it. It's all those LEDs, all of them are connected to the to our output, starting from E0, 1, 2 until 7. So nothing is complicated about the circuit. Let's go to our code, and I have prepared the code, and we will go through. So basically what we have here is of course the basics that we have learned so far, which is include the device, the microcontroller itself. This is dealing with the origin, from where I gotta start, and then go to start, so everything sets to 0, and then I'm gonna start to this place hexa 00, and then I go to start directly, and we have those here to deal with interrupts in case of any interrupts happen. So let's go through what is important from here, as this is the basics, and this is the something that it will be there all the time normally. So let's get into the code. Start. So from start here, first of all, I have to clarify my inputs and outputs. So of course, clear F trace D, that means our output is for D, and set F trace B, our input is for B. And then this is just only for clarification, while making sure that all ports D and B having no value are cleared. Then let's go to the check. Here we're gonna start checking our the button status, whether it's set. That means set, which is set here, it's clear. So if it's set, then it will of course skip the next line, as we have used the instruction bit FSS, which is bit test file skip set. That means it will skip the set. If the button is in the set mode, then it will skip the next line, which is on LED. That means it will skip the next line. It will go directly to port. It will directly jump from here to the next. Of course, here we are just clearing all the LEDs after making sure that even though if it's set or not set, we are clearing all the LEDs after this. As long as it's coming to the next, as long as it's skipping the branch on LED over here, and of course we have on LED E and on LED O. E stands for even, O stands for odd, to differentiate between both. So basically, if let's go through the code. If it's set, that means if the buttons are not pressed. Here, if it's set, then it will skip the next line. I mean port 0, we are talking about port 0. If it's set, skip next line. So it will skip the branch on the E. And then it will clear all LEDs, all even LEDs, and then it will go to check again the next button, which is in B1. The input is B1. So is it set? If it's set, yes, it will go again to clear all, and then it will go again to check. So that's how it goes if it's all set. And our code today, it's not only, in fact, it's a bit bounded code. It doesn't work if both buttons are pressed. So basically what we are doing over here is one of those buttons has to be on, the other has to be off. And if in order to press the next button, I have to off the first button and then turn on the next button. So yeah, that's what our code is dealing with today. So let's say if it's not set. If it's not set, then let's say here you press the button, then it will go to the next line, which is on LED E. So on LED E, it will go to here, it will branch out as we use the instruction branch. It will branch out to on LED E. So here we have our move LW. That means I'm taking this binary, which is 01010101. I'm taking it from, I'm saving it on the WREG. And after that, I'm taking it again, move WF. I'm taking all this data from WREG to the port D, to all ports D. So what is this binary doing? Quite easy. It's just in order. You will set up in order all LEDs. That means 01010101. As you can see in our device and in our device, the LEDs are, I mean the order of LEDs started from 1, 2, 3, 4, 5 until 8. So that's what's gonna happen. It means that the first LED is going to be off, second LED is on, third LED is off, fourth LED is on. Whenever it's 1, that means that LED is going to be on, and it will branch out again to next. So whenever it branch out again to next, we have to turn off the button first. You have to turn off the first button because that button is still on. Whenever it branch out to next here, the next button is still on set. We didn't press that button, so it will go directly to port D to clear everything and go back to check everything is normal. In case if you press the second button and both were working together, it will just go crazy. It will get into an endless loop of working, and even though if you turn it off on, the LEDs will never stop. And yeah, so basically if you want odd and even LEDs to work, you have to turn off the previous one. If you for example, if you turn on the even LEDs, turn it off first and then go to the next. So yeah, this is what happened. If let's say this is off and we have pressed the next button, the other button, then it will go to on LED off, and then it's the same thing. We are moving this data to the WREG, and again we are placing it on port D. So it's the opposite. It's just 1 0 1 0 1 0. That means here odd odd LEDs, LEDs with odd numbers in order are going to be working, and the others are not. So then it goes back to check. So I think that's all about the code. That's all about the code. I have already exported, and it's already here. So let's just make sure it. I will go the process of exporting again to. Okay, so we just press file. After you finish your, of course, we'll start with building the code to make sure that everything is correct, so build succeed. Okay, we close it, and then we go to file, export. Okay, I'll just rewrite whatever I have over here. Okay, now I go to ISIS and press on the microcontroller, edit properties, and go to this file over here. Press and choose your hex or whatever you have overwrite just now, and okay. So now let's try and play and run this. So it's running right now. So let's try and press the first button. As you can see, pressing this button, all LED are working. 1, 3, 5, and 7 off. And then on the next one, even LEDs are working. So this is our case. In case if I press 2 buttons right now, LEDs are going to be going crazy, and it will never off and on. Even if you're trying to off on, it's not working because it's stuck in the loop where it's going to place that data, which is the 0 1 0 1 0 1 and 1 0 1 0 1 0 1 0, and taking it and place it. And imagine that one LED is 0 and next second is 1, so it's going to be like 1 0 1 0 1 0 1 0 1. LEDs are working on and off, on and off, on and off. So yeah, thank you so much, and hope it was informative. Thank you.